two other brief comments. We do have air resistance in the room. Pendulum wasn't moving that fast, but the air resistance would tend to increase the period of the function. And also, I've got a slight correction up here. Careless with my decimal point. This should be 0.2006. So that this number would tend to increase a little bit. Now that doesn't mean that we really got all that close to the actual. We do have significant uncertainty here, and that can all be analyzed, but we're not going to go deeply into that analysis, at least not at this moment. Okay. And the other thing is, how do we get this? Well, that involves differential equations, but and that's the fourth semester of a rigorous calculus sequence. So actually the differential equation that governs this could be solved after one semester of calculus, but we wouldn't ordinarily see it until later. And the differential equation that takes account of air resistance, you really do have to have the full-blown 4 semesters to deal with that one. The other thing is, we've seen models of this type, and we've done them with Excel. The model being V prime equals negative G over L times X, where V is the rate of change of X, okay? In other words, X prime equals V. So we can plug in numbers. We can set this up in the way we've set up similar systems in Excel and use a small time increment, because again, the prime means the rate of change in time. But we could set that system up and get a good estimate of what this number ought to be. We're not going to get the 2 pi, and our result, well, will involve the value of G, because here's the value of G. So V prime equals negative G over L multiplied by X. That might be off the top of the screen depending on which video you're looking at. It might be partially visible. And then the X prime equals V. Now I'm not going to comment any further than that. I just want to bring that whole type of process into this investigation.